Hi, this is Graham from Main Street DBAs. Main Street DBAs is your go-to DBA resource with experts in SQL Server, MySQL, and Oracle, just to name a few. So if you'd like a dedicated, incredibly knowledgeable, and friendly DBA on your team, drop us a line at mainstreetdbas.com. Okay, today we're going to discuss non-clustered column store indexes.
You may have heard about column store indexes and how they can improve performance. Column store indexes can significantly improve query performance for large relational data warehouses. Alright, let's briefly discuss one of the key concepts of column store indexes, the column store. What is column store? Column store is data that is logically organized as a table with rows and columns and physically stored in a column-wise data format. This is different than row store. Row store is data that is logically organized as a table with rows and columns and then physically stored in a row-wise data format. This has been the traditional way to store relational table data. Okay, let's pause to think about how this storage difference is used to increase performance. In a typical B+ tree, each row of a table is stored on a page, and hopefully there's lots of rows in each page. For a column store index, the name says it all. Data is stored by column. This key difference can significantly improve aggregate queries like sum and averages because instead of grabbing the entire table row, now only the columns needed for the aggregate function are called. Storing the data by columns can improve data compression. I've seen disk storage savings of around 30% for data warehouse fact tables. High levels of compression can be achieved if the column data is redundant. However, the more unique the column data values are, the less compression gain you'll see. In this video, we're going to be demonstrating non-clustered column store indexes as opposed to clustered column store indexes. And unfortunately, non-clustered column store indexes are not updatable. It's read-only. To update the table and the non-clustered column store index, you can switch partitions in and out. You can also disable the index, update the table, and then rebuild the index. That's a bummer, but starting in SQL Server 2014, that's when clustered column store indexes were introduced, which are updatable. You can combine regular non-clustered and non-clustered column store indexes on the same table. When using them together, understand that the query optimizer has to determine whether to use the non-clustered column store index or the regular non-clustered index. If most of your queries would benefit from a non-clustered column store index, then it may be prudent to do away with the regular non-clustered index. Also remember to test, and then do some real testing before you go changing indexes in production. So when should you use non-clustered column store indexes? Well, they're most beneficial for large tables, especially data warehouse factor dimension tables, also where there's a high read-to-write ratio, and there are a lot of queries that reference a subset of a table's columns. Column store indexes may not be beneficial if used for OLTP systems with a lot of singleton operations and frequent single row CRUD operations. For more details on when to use column store indexes, check out Microsoft's Docs page, Column Store Indexes Design Guide. It's a really great reference. Alright, let's get to the demo. So we already created a database column store, and now we're going to create a sales table comprised of sales ID, customer ID, and sales amount, and insert 10 million records. I'll pause the video while that completes. Okay, that took just over a minute on my box with 2 virtual CPUs and 8 GB of RAM. Okay, now that the 10 million rows are populated, let's go and run our query. This query is comprised of the sum of the sale amount, the average of sale amount, standard deviation of sale amount, and grouped by customer ID. A very contrived, simplistic, analytical query. And at the top, you'll say I have drop clean buffers and free proc cache. This just makes sure that each time this query is executed, it's not using any kind of cached data pages or cached plan. Also, I have stats.io on and stats time on. Stats.io just helps measure the logical and physical reads coming out. Also, stats time helps measure the compilation and execution time of the query. So let's go ahead, highlight this, run it, and you can see that I had the actual query plan checked. So this is a way to gauge the overall cost of the query, and we can look at any kind of expensive operators. So I'll pause the video while this executes. Okay, I didn't really need to pause the video. The query completed in 21 seconds and returned 250,001 rows. Alright, let's look at the overall CPU time. 20 seconds. Let's record that. Let's look at the execution plan. The overall estimated subtree cost, 80. It's an expensive plan. Now, let's go on and see what a non-clustered index, or I should say what the query cost and runtime would be if we go ahead and apply a non-clustered index to this table. So we're going to create the non-clustered index with included columns now. And this is typically what you see to help these clustered index scans. Also, throwing the sales amount in the included column can help with the aggregate functions. So we'll run that. I'll pause the video while that completes. All right, the creation of the non-clustered index with the included columns took 50 seconds on this box. Now let's go back and run the query again and see what we get. Oh, wow, look at that. Returned almost instantaneously, but I'll pause the video while this completes. Okay, so already you can see a significant performance improvement. It's down from 20 seconds to 11 seconds. Let's take a look at the logical reads. So it's down from roughly 30,000 to 27,000. Not that big of a difference. CPU time is 6 seconds. Total elapsed time is 11 seconds. That's a nice improvement. All right, let's go check out the execution plan. Let me record this so we can keep it running. Evaluation for comparison. All right, let's look at the execution plan. For that, you can go over and see it actually used the non-clustered index to scan. Let's see the estimated subtree cost. All right, 35. That's over half reduction in wrong one. That's also over a half of a reduction in the total subtree cost. Now let's go and create a non-clustered Columnstore index and run this query again and see if we can get even more performance gains. Before we test the non-clustered Columnstore index, let's drop the non-clustered index just so the query doesn't accidentally use the non-clustered index. Let's go over here and create the non-clustered Columnstore index on the sales table, and as you can see, it has every column in the table in it. Now while it's executing, I'll pause the video. Okay, that took 35 seconds on this box. Now let's go back and run this query again. Remember to include the actual execution plan, free proc cache, drop clean buffers, and let's see if we can get even more performance improvement. Now I'll pause the video while that executes. It's not returning as quickly as a non-clustered Columnstore index, but oh, look, no need to pause the video. 6 seconds to return. Already a 50% performance improvement over the non-clustered index. Let's go and look at the logical reads. 21,000. So it's about a third less than nothing, which is all right. And let's go over and look at the execution plan. You can see it actually did the non-clustered Columnstore index scan. And let's look at the estimated subtree cost. All right, let's call that 8. So as you can see, there's dramatic performance improvement in execution time, not so much in the actual logical physical read time, but this definitely does scale out. So you can see that it's almost a third, or it's less than a third of just using a clustered index, and it's half as expensive and takes half as long to run as compared to using a non-clustered Columnstore. A non-clustered index. So a non-clustered Columnstore index is providing significant performance improvement. Okay, that's it for this video. And remember, this is a very contrived, simplistic example. Your environment will differ, and before you go and change index, drop, or adding, please test, and then do some more actual testing and documentation, because you don't want to just go in there and pulling things out or adding things in. You could significantly hamper performance. All right, thanks for watching.